Hey everyone, Mrs. Gifford here for lesson 8.6, quadratic equations and looking at perfect squares. And after this lesson, students will be able to factor and solve perfect square trinomials. So what is a perfect square trinomial? So it's a polynomial that has three terms. The first and third terms are perfect squares. And the middle term is 2 times the square roots of the first and the third terms. So, is this first term a perfect square in 16x squared? Yes, it is, because the square root of 16 is 4 and the square root of x squared is x. The last term is 9. Is it a perfect square? Yes, it is, because 3 times 3 makes 9. So we know the square root of 16 is 4. The square root of x squared is x. The square root of 9 is 3. And we want to check to see if this is 2 times, this middle term, if it's 2 times this product. 4x times 3 is 12x. Oops, 12x. And 12x times 2 is 24x. Excuse me. So this example is a perfect square trinomial because the first and last terms are perfect squares. And the middle number is twice the product, so 2 times the product of the square roots of the first and the third term. So let's talk about how to factor perfect square trinomials. And if you kind of use the example I did before, and here's looking at this little chart from the book, you factor them. If everything is adding, you can factor them as the square root of a squared, which is a, and the square root of b squared, which is b. Okay, in this case, because everything is positive, then we know it's the quantity of a plus b squared. And also, if you look at the second example, if the last term is positive and the middle term is negative, then kind of like what we did back in 8.3, then each of these is going to be subtraction inside the parentheses. So there's a couple of examples also, but let's talk through example number 1. The first question is this a perfect square trinomial? And if so, then we're going to factor it. So we have 9y squared plus 24y plus 16. The first thing we need to do is to decide if this is a perfect square trinomial. And to do that, we look at this first term. 9 we already know is a perfect square, and looking at y squared, yes, that's a perfect square also. And then looking at this last term, this plus 16, is a positive 16 also a perfect square? Yes, it is. So then we know that the square root of 9 is 3, and the square root of y squared is y. And we talked about the fact that the square root of 16 is 4. Now we need to check this middle term to see if it's twice the product of 3y times 4. And 3y times 4 is 24y. Oops, sorry. 3y times 4 is not 24y. 3y times 4 is, right, 12y. And 2 times 12y is 24y. So the first thing we say is, yes, this is a perfect square trinomial, and then we're going to factor it. So the easiest thing to notice is we're going to use the stuff that we already have here. And because it's adding in the middle and a positive at the end, we know that completely factored, this is 3y plus 4 quantity squared. If you wanted to write it out the long way, it would be the quantity of 3y plus 4 times the quantity of 3y plus 4. But going up above, if you see that it's a perfect square trinomial without adding, it's just you can take the one term and then square it. So what are the different factoring methods that we can think of? So the first thing that we can do is we can factor out the greatest common factor. That's something that we did earlier in the chapter. Check for differences of squares or perfect square trinomials. and apply any factoring patterns or rules that we've talked about or factor by grouping. So as we look at example number 2, we're going to factor this particular polynomial. So the first thing that I notice, if we look at step 1, it says factor out the greatest common factor. In this case, we have 2x squared minus 32, so I think to myself, is there a number or is there something I can factor out of both of them? And the answer in this case is 2. So I'm going to factor this 2 out, and this 2 is going to come outside the parentheses, and 2x squared divided by 2 leaves us with x squared, minus, and then 32 divided by 2 is 16. So then we say, okay, step number 2, now that we factored that out, step number 2 says check for a difference of squares or a perfect square trinomial. So in this case, we only have 2 terms, so we know it's not a trinomial. So then I'm going to check to see if it's a difference of squares. Difference meaning subtraction, squares meaning perfect squares, and we know x squared is perfect and we know 16 is perfect. So then we're going to use what we know about factoring to say, okay, well, my 2 is outside the parentheses, and because this is a difference of squares, each parentheses is going to get an x, each of them is going to get a 4, one gets adding 4, and one gets subtracting 4. So this is showing that our polynomial is completely factored. Now, we want to solve this equation. And we have a squared plus 12a plus 36, and we're going to use all of these factors in order to help us solve this particular equation. So we have a squared plus 12a plus 36. So the first thing that we need to do is look for a greatest common factor. There isn't one. Then we look for difference of squares or perfect square trinomial. Well, it's a trinomial. Now we have to decide if it's a perfect square trinomial. A squared is a perfect square. 36 is a perfect square. And let's look to see if the middle is 2 times this product. And a times 6 is 6a. And 2 times 6a is 12a. So we know that this is a perfect square trinomial. So then we know that it's the quantity of a plus 6, quantity squared, and this is all equal to 0. And we want to solve this equation, so we take this one term, this a plus 6. Okay, if you think back to what we did back in 8.3, we set each factor to 0 and solved. And because it's the same one because of this squared, all we have to do is take this a plus 6 and set just the one of them equal to 0. And solving equations, we want to subtract 6 from both sides, and then we say that our solution is a is equal to -6. The other thing that we want to do is check our answer just to make sure that we haven't done anything wrong. So we're going to take that -6 and put it back into our original equation. So we have -6 squared plus 12 times -6 plus 36, and we're checking to see if this is equal to 0. -6 squared is 36, plus 12 times -6 is -72, plus 36. Well, I see that I have 36 plus 36 is 72, and 72 plus -72 is 0, which is exactly what we wanted. So now we're going to take this other thing, this next one called the square root property. So we first of all want to talk about what this property is. And so when we look at problems that where we have x squared equals a number, n is a number, this n is a number, then we're going to take the square root of both sides to solve. And the answer to this particular problem is plus or minus the positive or negative value of the square root of whatever that plain old number is. Okay, that plain constant. So let's take a look at example number 4, and we're going to solve this equation. So we have the quantity of z plus 3 squared is equal to 26. So again, when we have a problem like this, the first thing that we're going to do is take the square root of both sides. And the square root of something squared is just what's underneath the radical symbol, so 0, or inside the parentheses in this case. So we have z plus 3. And as the square root property says, we're going to take the square root of that right-hand side. And we know that 26 is not a perfect square. So then we can write plus or minus square root of 26. Now, as with solving all equations, we want this variable to be by itself. So we're going to subtract 3 from both sides. And then our solution is z equals negative 3 plus or minus the square root of 26. If your answer choices, if this is multiple choice, if your answer choices have the radical symbol, you can leave it as this. But if they're not, then what you can do is take the two different answers, and we have negative 3 plus square root of 26 and negative 3 minus the square root of 26. And then to simplify it further, you can find the square root of 26 and then simply take negative 3 plus that square root of 26, and then you can do negative 3 minus that square root of 26. And I should have had a calculator handy so I could do this for you real quick. But the square root of 26 is we'll call it it's 0.99, so we'll call it 5.1. So if we have to figure out what the exact value is, or close to the exact value, I rounded my square root of 26 to 5.1. In this case, we would say 2.1. And then we have negative 3 minus 5.1, and we have negative 8.1. So most of the time, this particular answer, this negative 3 plus or minus 26, is just fine as far as your answer goes. So there you have it for 8.6.